Dr. Sadek, if you want to maybe start with some remarks or welcoming the audience.
Yeah, thank you very much, Dr. Najran. This is our first session. I understand that Dr. Najran is trying to arrange, especially for our manufacturing students. And the idea is to, as manufacturing is our new program, and our idea is to make sure that students fully understand what is manufacturing is all about. And because there are lots of questions we all the time hear from the students regarding the difference between manufacturing and mechanical or maybe some other disciplines of engineering, and where are the job opportunities. So we thought of conducting this session and try to give as much as information to our students through this session. So I welcome everyone. I hope everyone is safe and healthy. So I'll request Dr. Najran to to conduct this session, and I'll be here if there's any specific question comes. And I also happy to see Michael Benoit, who is our new faculty member. I think he's sitting somewhere in Australia, and also joining for this session. How are you, Mike?
Very good, thank you.
Great. So over to you, Dr. Najran.
Thank you very much. I appreciate it. As mentioned, the purpose of this roundtable today is, number one, we want to put some faces to the names of the faculty members who are supporting us in building and also expanding our manufacturing program. And we have specifically asked the students who have been in the program, Miguel, and who have decided to join the program, Vanya, to come and run this roundtable for us. And remember what was the questions they had the last year at this time, and if there is any support and help we can provide in this session to clarify those remaining questions is basically the purpose of today. And because of that, we would also like to focus the questions around what kind of vision and mission we have for this program, what are the type of equipments that we have, and we have also foreseen some questions that we hopefully will be asked about what is the difference between this manufacturing program and the existing program at the school. And hopefully with this clarification, we can expect more people to choose manufacturing as their future career.
Yeah, so I guess we'll take over now. I'm Miguel. I'm going to my third year. I was part of the first year of manufacturing students. I'm also the manufacturing rep on the Engineering Society Council. So I guess you'll see me everywhere. I don't know, Vanya, do you want to introduce yourself?
Okay, I'm Vanya. I just finished my first year of engineering, currently going to my second year. And I'm currently at home with family in Vancouver. And I think that's it.
Yeah, I don't know if the professors want to introduce themselves now, Dr. Najran, Dean, Hassan, and Michael.
Yeah, so I'll share actually some slides here that we kind of created to introduce each one of us. Yeah, so I guess these are kind of the main faculty that are associated with the manufacturing program. Of course, we have Dr. Sadiq and Dr. Huarfar, who are kind of our senior executive associate dean and directors of the school. And then we have Dr. Najran, who is the program chair of the program. We have Michael Benoit, who is a new assistant professor who will be joining us in January 2021. Myself, I'm an instructor in the manufacturing program. Hassan is a lecturer in the program. Mehran, who is also a lecturer, and he's associated with the mechatronics option. And the program's growing, so is the faculty. So we have lots of hiring going on and future faculty that will be joining us. So. Yeah, not sure, Dr. Najran, if you want to say a little bit about yourself.
Thank you. Thanks, Dean. So, name is Humayun Najran. I'm a professor of mechanical and mechatronics engineering. My field of research relates to automation, robotics, and control. I joined the school May 2006. I was therefore one of the pioneers of the new campus of UBC, starting the School of Engineering. So manufacturing is of course a new program at the School of Engineering, but this endeavor is not new to me. A few years back, mechanical, electrical, and civil engineering were new programs of UBC as well. So we have been quite experienced in building new programs. In that sense, although manufacturing wasn't exactly my field, but I was blessed to be tasked to help the school to build this new program. So we have some experience in that. And the reason that I was interested in jumping in and taking this opportunity at the School of Engineering was because in 2016, being a control engineer and being a person involved in robotics and automation, there was, during some visits to different countries and different conferences and different venues, we noticed that manufacturing is moving more and more towards artificial intelligence, use of smart and intelligent machines and sensors. I saw an opportunity for myself to start being more involved in that field. And because of the new messages we had, this opportunity for manufacturing came. So to explain what the research of my laboratories, we focus mainly on industrial automation that nowadays they call it Industry 4.0 and microelectromechanical systems. I also do research around the autonomous vehicles and self-driving cars or unmanned aerial vehicles, including drones and fixed-wing airplanes. Also, my focus and the main contribution of my lab is around the applications of artificial intelligence. That nowadays you've probably heard about deep learning, machine learning, and we have many collaborations with different countries, including France, for example, IFSTAR, with which we in France we work on driverless cars. DLR, German Aerospace Institute, with which we work around advanced manufacturing. Thank you very much.
Yeah. Hi, everyone. My name is Michael Bruno. I'll be starting as an assistant professor on the manufacturing program as of January 2021. And I thought I'd just kind of give you a quick background on a few different aspects of my life. And the first one, I guess, would be on sort of where I'm from and my education and research interests, and then I'll quickly give you some perspective into my experience with industry as well. So, Dean, maybe if you could just scroll through two more. Yeah. So this is just kind of a map of where I originally came from, which was southwestern Ontario, small city called St. Thomas, but it was the railway capital of Canada. I lived there all my life until I moved to Waterloo, where I did both my undergrad and PhD. So I spent about 10 years at the University of Waterloo and did both of my degrees in mechanical engineering. And really, my research during the PhD was around welding and joining of metals, specifically looking at brazing of aluminum alloys. At the end of 2018, I had the opportunity to move to Melbourne, Australia, which is where I am right now, to conduct some more research. This time I was looking at developing some aluminum alloys, some high strength and crack resistant alloys for additive manufacturing processes. And then toward the end of this year, I'll move back to Canada, but this time I'll move to the West Coast to BC to join the faculty at UBCO. And then I'll just quickly run through. So over the past 10, 12 years or so, I've had the opportunity to gain a lot of varied experience with industry. A lot of it was around southwestern Ontario, because that's where, like I said, I grew up. And a lot of the companies that I did co-op placements with were in southwestern Ontario. But I also had some other really interesting opportunities. For example, my first co-op at Waterloo was working at a university in northwest India, and we learned a lot of practical hands-on manufacturing processes there. Also had the opportunity to work down in Boston for about 8 months developing some grid-level energy storage devices. And Dean, if you go one more. Yeah, and then probably the company I was associated with the longest was the company I did my PhD with. So I had a lot of opportunity to work in their industrial R&D facility, testing out some of the ideas we developed in the lab at Waterloo. Yeah, so let's give you an idea of my industry experience. I think I already touched on some of my research interests, which are really around joining of materials, so things like welding, brazing, soldering, and more generally looking at the processing chain of materials. So how does what we do to the material affect their downstream performance and microstructure? As I also mentioned, I'm currently involved in a lot of additive manufacturing research. So it's a very interesting time to be in that area. And again, understanding how things like the alloy design and processing routes will affect our final products that we create in this process. In terms of the teaching, past teaching experience and teaching interests, a lot of it's been around materials and metallurgy and welding and joining processes. And that's a lot of the stuff I've done in the past. I'm currently involved, not with necessarily teaching a course, but supervising a number of capstone or fourth-year engineering design projects, and a lot of those are focused around additive manufacturing as well. And I believe when I moved to UBCO, it looks like the first course at least I'll be teaching is the Engineering 439, which is I guess a third-year manufacturing engineering course. And then the last slide is just just some of my other more general interests outside of research and teaching. So I know I like to do a lot of reading. Pretty active in Muay Thai, Jiu-Jitsu, a lot of things just being active. I'm also very involved in, when I was in Canada, taking care of or fostering some animals from the Humane Society. And currently I have a seeing eye dog puppy, which I'm training for Vision Australia. So just to give you an idea of some of my other interests outside of the university.
So actually, a lot of you already know me. I recognize some of the names that are popping up because I taught everyone in first year calculus. So quick introduction in terms of my education and research background. So I did my undergraduate and my master's degree at the University of Calgary in the area of adaptive robot manipulators or adaptive robot control. And then I moved down to California for about 6 years, where I did my PhD at the University of California in San Diego. And then decided to come home and did a postdoc at the University of Calgary. And my research there was developing sensor networks for the city of Calgary for urban noise monitoring. In terms of my industry experience, I worked for a company in San Diego called ASML. It's actually a Dutch company, and they develop manufacturing equipment for computer chip manufacturers. So chances are, if you have a smartphone, it's been manufactured by the machines that we were working on. And just to give you a little bit of a scale of, this machine, I put a little human figure in the bottom right here, and this bottom right module of the scanner system here is what I was working on. So I think this kind of gives you a little bit of a different perspective of manufacturing. It's definitely a cutting edge field these days. We're using cutting edge technology, and it's people in bunny suits in clean rooms, not just, big, manufacturing equipment that you're kind of think of when you think of traditional manufacturing. So in terms of teaching, I teach a lot of fundamental engineering courses, but for the manufacturing program in particular, I'll be teaching 386, which is industrial automation. So we'll be focusing on control systems, actuators, and sensors. And I'll also be teaching a measurements and instrumentation course. As an instructor, I also have an educational leadership role within the school. And some of the initiatives that I'm pursuing in that role are incorporating industry certification into the manufacturing program. So we're working closely with Festo and a certification organization called NC3. And the idea is that if you are a manufacturing engineer, you can take your manufacturing courses, and you also qualify to take industry recognized certifications as well that you can kind of add to your CV when you're going out and looking for jobs. I'm also involved in, I'm also involving students in my curriculum development. So I've employed quite a few students over the summer to try and help me with the development of the labs for the manufacturing program. In terms of personal interests, I'm a big outdoors guy. I love hiking, backpacking, and rock climbing. I even see, not to point you out, Ethan, but Ethan and I often run across each other in the rock climbing gym. And the last kind of piece of personal information is that I'm expecting a child in July, which is terrifying for me. So wish me luck.
We will, yeah.
Thank you very much. I'm Hassan. I'll give my little bit background. I actually did my undergrad from University in Pakistan in 2000. And then I in different fields of mechanical engineering. My basic degree is in mechanical engineering. I started my career as a piping engineer in EPC. EPC we called engineering, procurement, and construction companies, those who design chemical plants and oil refineries. So I worked 1 year as a piping engineer there. Then the CNC machines fascinate me a lot. And then I went to China, got their training, and I started my own business. I run my own business for 5 years for automobile industries. I have a setup to manufacture sheet metal and injection molding components most of the time, and also a lot of machining activities. And then on that basis, I've been appointed by the Automobile Association to the government of Pakistan as a project director. I established a couple of incubation centers where the different technologies related to the manufacturing being introduced to the local industry. And at that time, I was a part of task force, which was working with the OEMs. The three famous OEMs are working there, Honda, Toyota, and Suzuki. And our main focus was on the lean manufacturing there. And from there, I actually accidentally entered in academia. My parent institution, they called me to develop their manufacturing labs. And they hired me as a research engineer there, a research officer. I shifted my career from my own business industry to the academia, spent 2 years over there. Then I've been appointed, I got a job in King Fahd University of Saudi Arabia. As a lecturer, I taught 5 years manufacturing program over there. And then I came here, and at that time I realized like PhD is now my path. So I got admission here in UBC of Nagan. I did my PhD from here. And then I started I joined this program. So I have both experience in in industry, around 9 years in industry, and then almost, you can say 7-8 years if I remove my PhD time. So it's in academia also. I will actually teach, right now I'm teaching ENGR 416, which is CAD/CAM CAE, and I have already taught MANF 230 and MANF 270, which is manufacturing processes. Actually, its title is not manufacturing processes, but we are actually focusing on those. So this is called the manufacturing lab. And the 270 is production management. Some of people probably didn't know me because I already taught this course. And other than the teaching, I have some other hobbies. I love to do woodworking. Here you can see I have made a lot of epoxy river tables. Gardening is my hobby. Outdoor camping. Cooking is one of my, again, a hobby. And then photography. So we can talk about that, and videography also. I have drone. I have a lot of landscape videos. So that's all. Thank you.
Hello, I'm Mehran. I think we know each other. We had 173 until last week, a couple of weeks ago. Good to see your names again here. I got my bachelor's in electrical engineering with the specialization in control. And I remember when I graduated, I wish I had many skills I didn't have. I looked at the job ads and there were many requirements which I didn't have. Now that I see this manufacturing program, I can see all those skills are being taught. I feel a little bit jealous of you. You have the opportunity to take this program. I wish I could take it too. It's very interesting. I have seen all the labs prepared by the group and all the equipment, all the courses. They are so exciting and they are exactly what the industry needs. So they will be very useful for you. I joined UBC exactly 1 year ago. In the last 1 year, I have taught 8 courses. One of the courses which I'm very excited about is that ENGR 494, Autonomous Vehicle Technology. Driverless cars have a very bright future in the next few years. There will be lots of job openings, and that would be exactly when you graduate. I think if you are interested in this field, this course and this program will help you a lot find a very good job after you graduate. I also teach the robotics course and the control course, digital control course and systems control next year. So they are all very useful after you graduate. Thank you.
Before we move on, I wanted to say, so the students that are here and probably some faculty members that have questions, if you guys could please send it to the Zoom chat so that we could start seeing them, and then when it's time to ask all the questions, it will be moving and flowing smoothly.
Okay, so if I understood you correctly, you were asking the students if they have questions, they can send it to the chat room, right?
Yes.
I guess while we wait for questions to come in, Dr. Nashran, if you just want to kind of describe the manufacturing program and talk a little bit about, the vision and the mission of it.
Sure, thank you. So I think the idea comes from, let's start with what manufacturing is in a general definition for it. Basically, you have this raw material and you want to take it into certain processes and make something, a product that can be of use for us. So as an engineer, however, this is not something that we take the material to our garage and start hammering it and making it to form a particular shape. It has to go through a scientific and technical process, starting, for example, from design, that is an engineering skill. So in our manufacturing program, therefore, we start by teaching our students what the concept of design is and what are the tools with which you can implement a proper design that is conventionally accepted and it can be universally understood in the world. And then after that, the second step in that process is we have to go and do certain analysis. I mentioned that manufacturing is taking raw material and turning them into a product. Therefore, we are going to, in our manufacturing program, show you the techniques. And nowadays, these techniques involve a lot of analysis using mathematical equations. It involves also numerical analysis, where you use computers and the software to do part of this analysis for you. After we figure out if our design is workable and it's appropriate, then we take it into the next step, which is now the actual process of manufacturing, in which then we go and implement our design according to the analysis and the results we've got through our analysis and in manufacturing. So our manufacturing program, therefore, is this complete set of processes which takes everything from a concept to the design, to the analysis, and finally to the manufacturing. And going back to what Dr. Shirazi was saying, different programs, they have different emphasis on part of this process. But in order to be able to a good and capable manufacturing engineer who can go and work outside, you have to have the entire tool set. You cannot just forget the fact that you need the analysis or you need the manufacturing. So the whole program has been designed so that we can teach our students the entire process, from the materials to that product. The mission and vision of the program you asked for is that we would like to make sure that this process that we are going to teach our students is relevant to the today's industry. And I give you an example. Say, for example, if you ask an engineer, what is a pipe? The way that an engineer, a mechanical engineer, will look at a pipe thinks it's a cylinder that has a certain diameter and it has a certain length. Doesn't care how it's manufactured. 300 years ago, a pipe for a mechanical engineer meant the same cylinder. 500 years from now, it's going to mean the same thing. But for a manufacturing engineer, the moment that you say a pipe, he thinks, oh, I can make that cylinder in different ways. I can extrude it. I can take a metal sheet and helically, I'm going to weld it. And you can imagine if that is the way that you want to think about that product, 100 years ago, today, and 500 years from now, these processes may be different because now we have different machines, different processes with which we can make the same cylinder. So therefore, it is very important that we have to look into forward and we have to think what is relevant to the industry today. Not only that, if you are a manufacturing engineer, you graduated, you have to share this vision with us. You have to keep yourself up to date. So in this process, when you come to the UBC manufacturing community, you will have to stay with us forever. It's not just a 4-year program and then you shake our hands and you go and work. You have to stay connected because we promise you that we will keep you updated in this journey.
Thank you so much. So, seeing as the program is a new one, it's just newly on campus and everything. So what does one expect the size of the class to be? And even the faculty member, like what size are you looking forward to see? Like someone like me, what am I going to like? Am I going to see a big crowd? Am I going to see a few students? What am I going to see?
So we would like to keep this mission, in a sense, nimble. So I mentioned that we have this engineer is going to be quite specialized and is going to have the entire skill set. But when you are specialized in a field, you may not be able to cover the general area. So in other words, if we go and produce 200 manufacturing engineers, tomorrow we may not have 200 job opportunities for them. So it is important that we go and make sure, this is also the mandate of the school, that always keep an eye on what is the job market, because we do not want to have surplus of manufacturing engineers that then they bring their salary down. So we are keeping an eye on that. Right now, the province of BC, Canada, and the world needs these engineers in big numbers. But that doesn't mean that we have to go into mass production like mechanical engineering or electrical engineering or civil engineering. So that's one aspect. So we have to keep our student number between 25 to 30 to 40 to 50 maximum. Whereas in mechanical, we may go up to 250 and there is no limit to it because it's quite generic. That's in terms of the size of the program for students. But in terms of faculty members, we are lucky that we are in an environment called School of Engineering, in which boundaries are quite, I would say, vague and fuzzy. It's not, we don't have a department for manufacturing engineering that needs 40 faculty members. So right now we have guests here, myself, I'm a mechanical and a mechatronics. Dr. Shirazi is with the School of Engineering and covers all different courses. So Dr. Richard mentioned he's taught to all of our students. Dr. Iqbal is covering mechanical and also manufacturing courses. So in that sense, we are going to tap into our existing resources. So I would imagine that we'll have somewhere between 10 to 12 new faculty members to manufacturing. And that would be quite plenty because we also have another 60 professors in other programs that are going to help this. So I don't know if Dr. Sadiq can maybe add to this vision.
As Dr. Najran mentioned, this is a very niche program, and we don't want to have a program which is very big and there are not enough opportunities in that specific area. I feel that it will evolve over time. Our initial thought is to keeping a program very small and focus on very specific field. As Dr. Najran mentioned and many of our other colleagues mentioned, there are some very interesting opportunities, especially around Industry 4.0, robotics, and we can list it long. But what it is basically, we would like to give our students a very different experience. And I saw in the chat box, maybe Dr. John and other faculty members will talk about the difference between the disciplines with manufacturing. My feeling is that depending on the type of people we're going to hire, it will evolve over time. But we really would like to see through manufacturing program that once our students are coming out, they have a good market for their employability. They are way ahead. They should be able to differentiate between a mechanical engineer and a manufacturing engineer. So I'm very, this is one of the things which we have seen evolved over last 3-4 years in our school. This is one of the main initiative we have taken during this period. So we want to make sure that we will do state of the art, and other commitment I have for this program and with working with applied science in Vancouver to hire high quality 15 in the range of 15 to 16 professors. So it's a very rare opportunity. I believe once our hiring will be done in our school, we will have professors and our teaching professors and our lecturers will be covering all state of the art, what's happening in the discipline. I would say we should be a little bit ahead of the curve in this regard. So I'm very excited about it, and we're happy to hear some questions and the response to those questions by our faculty members.
I guess we'll go to some questions in the chat now. Cherry asked, what's the difference between mechanical and manufacturing?
Okay, thank you very much. Yeah, this is a very common question. And when this program started, some students, they came to me and they asked the same question: what's the difference between mechanical and manufacturing? There is no difference. This is the same engineering. So then question may come, why do we have this manufacturing program? So just to make it easy, I'll give you example. And that example people you like a lot. Everyone loves cars. So when any OEM, when I say OEM, mean original equipment manufacturers, like Toyota is OEM, like Honda is OEM, Ford is OEM. So when OEM, they design any car, they need mechanical engineers, those who design its aerodynamics, its engines, its suspensions, whatever its design aspect. Then they need a mechanical engineers, those who convert that design into the tangible products and like the real components, like how to make an engine block, how to make those upholsters, how to make those sheet metal body. Here is those mechanical engineers are called the manufacturing engineers. And then in the same industry, there's another type of engineers, they require those who manage all resources. And we call them the industrial engineers. So the manufacturing engineers, those are actually blend of mechanical engineering. They are also blend of industrial engineering, and right now also some blend of electrical. So it become a mechatronics or the electrical or electronics and mechanical mix. So this is a very unique program, and I would like to share my experience when I graduated. And most of the time at that time, this type of specialty was only either you join that type of industry and with the passage of time you learn that skill set, or you have a master's program. So whenever we go in industry, we face a lot of it happened to me. I face a lot of resistance from the people who are working in industry because they are highly skilled in especially how to make a stuff. And when we mechanical engineers go there, we are good in the calculations, but we don't know how to make a stuff. So when we talk about this manufacturing program, so these mechanical engineers in other sense, but I'll say here the more specifically manufacturing engineers will be equipped with the design aspect, how to manufacture something. Like they're probably not very deep into how what is going on inside the combustion chamber of an engine, but they will be very well equipped and well trained how to manufacture the whole engine block, how to manufacture the pistons, how to manufacture crankshaft, connecting rods, all those things. They will be actually ready to do all those things. So this is that's why, and again, most of many mechanical industry, if I talk about the EPC, engineering, procurement, construction, they need a mechanical engineers, pure by design, but they also need mechanical manufacturing engineers because they have to they have to develop pipes, valves, and all those things. Same stuff in the automobile industry. Same in shipping industry. Everywhere, manufacturing engineers have the same opportunities. And in many universities, this program is called the applied mechanical.
Thank you for the answer. I kind of got something from me. So the next question says, apparently I think it was answered by Renee. And then the next one is, I heard that there's a miniature factory production line being constructed for manufacturing students. I'm just interested on its completion date. So when is it going to be done?
So one of the differences and objectives of building this manufacturing as opposed to the existing program was that if we would like to bring additional hands-on experience to our students, we'd better be more specific. And that was part of our vision for the manufacturing program. So the laboratory experience for this program is going to be completely different. So in that regard, what we are trying to do is to go into the world and see what are the best options for this hands-on training. And as Dr. Richard mentioned, one of the companies which is quite a pioneer and also quite advanced in Industry 4.0 is Festo. That is a German company that, number one, it has a big footprint on automation in the world. And number two, after the World War II, they have had the mandate of training engineers in Germany. And you can imagine engineering in Germany is quite advanced. So if Festo is in charge of training engineers in Germany, that is probably something for us to consider. So with that in mind, we have approached them, and number one, we have created a structure for our laboratories that on the one hand is going to be going into the traditional manufacturing procedures. And as I mentioned, we want to cover everything from design to analysis and then to manufacturing. And today's world, this process is completely digitalized. That is, everything is done with a computer to help. So computer-aided design, computer-aided analysis, and computer-aided manufacturing. So this process is one set of labs that we are building. And on the other hand, the question that you mentioned about this miniaturized factory is in fact something that we call it the Industry 4.0 lab, that has the cyber physical factory, that is realization of a digitalization of manufacturing in the factory. The beauty of that is that we have, although this is a miniaturized setup, it is going to be exactly run and executed the same way that all manufacturing plants in the world are running. For example, Mercedes, BMW, Bosch, and all these companies, they use exactly the same software. So if you are trained on this miniaturized version, when you go out there, you have been trained to work with those systems, and this is completely scalable. So in terms of timeline, everything has been considered. We are doing the final checks and balances to make sure that we get the best and most effective training for you. So please remember that's a huge investment, and we do not want to just jump in and buy something that is not going to give you the best experience. So we have a feeling that before you get into your year 3 and you go into these labs, these have been installed and you can start using them. And all I can promise is that everything is in the process. And with the COVID-19 in play, we are been slowed down a little bit, which we are trying to work around that. So I don't know, Dean, do you want to add a little bit about some more technical aspects of this, and maybe then we ask Dr. Sadiq if we can have his point of view.
I think you did a good summary, but one thing I did want to emphasize is that you brought up another good distinction between the MEC program and the manufacturing program, and that is the fact that all of these manufacturing processes are increasingly digitalized and computer aided. And so in this program, you will be taking some more software or computer science courses, and dealing a lot more with some more data science type aspects associated with the Industry 4.0 revolution. So I think that's pretty much all I wanted to add about that. Oh, sorry. One more thing I did want to add about distinction is I'm going to give you an example of the course that I'll be teaching to the third year manufacturing students. It's a course called Industrial Automation, and that course we really are going to focus on how to actually build the infrastructure to actually implement a control system. And I know I'm going to kind of piggyback on Mehran's comment that when he graduated, he felt like he didn't have any kind of tangible skills that were required or demanded by industry. And I felt the exact same way. I was very strong in control theory. In fact, I had a PhD in control theory, but I couldn't build a control system. And I feel like the course that we're trying to design for the manufacturing students, you're going to graduate and you're going to be able to go and actually implement a control system in real hardware kind of immediately after you graduate.
So, Dr. Sadiq, do you have anything to add, like bigger picture, how the university sees this installation?
Yeah, I can talk in a very non-technical way about our support to the manufacturing program. So, for all the students, for your, I just want to make sure that you understand that we are fully committed to provide all the resources for this program. It's a new program which requires, I don't want to put a direct dollar value to it, but it requires significant amount of resources, and which we are committed. And what my understanding is of talking to the manufacturing team and having lots of discussion, working with the provost on our campus as well as the dean in Vancouver, this will be a state-of-the-art lab facilities. I can ensure that. And there will be 4 different labs, which maybe Dr. Najran maybe mentioned later on, which we are trying to equip over time. As with COVID-19, we are all facing the challenge of supply chain. But the reality is that whenever it takes, when the program will be in a year's time, I would say, you will be able to see, and all of you will be experiencing hands-on experience on this equipment. So that's the commitment you can have it from the school.
Thank you very much. And just now that Dr. Shirazi is here, I would like to borrow his brain here. We want to also emphasize, I mentioned this, that although we have this new program, but it is connecting itself, and for the lack of a better word, we are taking advantage of other programs too. And part of this, we are going to strengthen our robotics capacity in the school as well. And he has agreed to help us with building this interesting robotics lab for the manufacturing program.
Yes, we are starting to work on building a robotics lab, which I have heard that UBC Vancouver is also going to copy what we are doing. It's going to be a very interesting lab on robotics using the state-of-the-art robotic arms and manipulators. So yes, it gives you a very good feeling playing with these robots, controlling them, moving them, picking up objects, putting on the places, on the targets, and it's exactly what it's being done in the industry, and you will experience this. You will design controllers and robots which do that for you.
Next one says, what does a typical manufacturing engineer actually do on a day-to-day basis? I don't quite understand how they fit into the engineering workplace. I hope that's the question. I hope that question hasn't been asked yet. Yeah, it hasn't been asked. So what does a manufacturing engineer do on a day-to-day basis? Like, what do you do?
I mean, I can speak to it a little bit. I think in terms of what they do on a day-to-day basis will vary a little bit depending on the specific role that they have. We have to figure out, okay, we have something that needs to be made. It's something that's being designed by our mechanical engineering colleagues. And really, we need to figure out how are we actually going to make this component. In terms of the actual processes that we're going to use to create it, we have to consider things like the materials. How should they be processed? What are the steps that we need to take in order to actually make that part? And then, within the actual facility itself, how can we plan our facility so that we can have those steps integrated into one continuous process so that it's actually made in a very efficient manner. And I mean, I can't speak too much to the automation and control side because it's not really my background, but there's a lot of that involved as well.
Yeah, I can comment a little bit on that. So my job as an algorithms engineer was basically to optimize our manufacturing processes. So of course we had a kind of a working control system, but it wasn't really robust and optimized in the way that we wanted. So part of my job was to, design experiments, go and prototype different control systems, collect data, analyze the data, and see how we can use that data to make our processes more efficient, more robust. And basically that just meant, cheaper for the consumer in the end. So that was, that's from the automation perspective.
I would also like to comment on that based on my industry experience. So all those industries, those who manufacture parts, mechanical engineers or manufacturing engineers, right? Because right now I will call them manufacturing engineers. They do everything, like they do a complete process planning. Then being involved in the even as CNC programming, the design for manufacturing, and then completely material resource planning. These type of all stuff they do on day-to-day basis based on in which department they are working. If they are working in product development, they will work on the complete production, the process planning. If they are working on the production line, they will do the production planning and control. And they do pretty much everything, which you really think, because the manufacturing is a new field, so people assign those work to the mechanical engineers, but actually the manufacturing engineers they do.
So I think one of the previous questions was it was typed in wrong. So sorry, I meant to say, will specializing in manufacturing prevent me from tapping into mechanical engineering job market? Or are they still similar to a point that I can get a mechanical engineering job?
I can speak for that. You see, it is a matter of, even if you do, say, for example, a mechanical engineering degree, when it comes to the fourth year, and that's the whole purpose of those technical electives. So all engineers, they do the same first year because they learn the fundamentals. They learn how you take science and apply it. So that is the foundation. It works for everybody. And in the second year, when, for example, they specialize in mechanical engineering, they go and now learn the fundamentals of mechanical engineering. And again, here for manufacturing and for mechanical, it's common. And also in the third year, now they go and optimize those skills, which is still common between mechanical and manufacturing. So it comes in the fourth year. Even if you go very broad, like a mechanical engineering, in the fourth year, you start picking some interest. So somebody may go into, for example, fluid mechanics and focuses, I want to be an HVAC engineer. So if you are targeting to go out and work in the fourth year, you have to start now think a little bit more narrowly into what you want to be in the future. So I would say if you go and do manufacturing engineering, up to the third year, you are more or less with a little bit more hands-on experience, automation experience, and computer engineering experience, but you are at the same level of understanding with mechanical, with some things which are a little bit faster and enhanced. But when you go to the fourth year, then you have made your mind that I want to be a mechanical engineer, but with manufacturing set of skills. So that person may not be a biomedical engineer anymore, may not be an HVAC consultant anymore, will be a manufacturer engineer, but it has that backbone of mechanical engineering. So if you want to go and work, for example, for an HVAC company and design, for example, heating and ventilation for a house, I would say it has to go and do a little bit of self-training of the last year of mechanical engineering. But still is a mechanical engineer, and in a factory can do all kind of different things that a mechanical can do, and even better because it's been trained for that kind of environment.
I would like to add a little bit in that. Many manufacturing industry, they don't hire mechanical engineers because mechanical engineers, they don't have that right skill set, and they are not beneficial for their industry. So they hire mostly people from the colleges like BCIT. And after having this manufacturing engineering program and this skill set, you will also have a chance to enter in that industry, those who are not entertaining right now mechanical engineers. This I have first-hand knowledge and experience. I attended one conference in Vancouver. Over there, I met a couple of manufacturing industry people there, and they said the mechanical engineers are not equipped with the right skill set what we need for the manufacturing industry. So they always look at the BCIT students. So that is a big place where you can have opportunity. And other advantage of manufacturing engineer, being a manufacturing engineer, you can start your own business at the small level, as a medium enterprises and the large enterprises, anywhere you can go, but you can start your own business. Many companies, they need a components, and sometimes engineers are not able to do that type of job, and then technicians or the college students, college graduates, they come and they start the small businesses. So this program is designed in a way that you have all those necessary skill sets which are probably help you to start your own business.
One thing I need to also add specifically with respect to this question is, if you look at the job market for mechanical engineers, it is mostly in the manufacturing sector. Unless you want to go and become a professor, or, mechanical engineering gives you a foundation, is a little bit broader, but it doesn't specialize you for any jobs. I would say out there, 95% of the jobs for mechanical engineering are in the manufacturing sector. So if you want to go and work after graduation, probably manufacturing brings you closer to that job.
What can I do now to start my career, to kickstart my career as a manufacturing engineer, or do I wait after graduation to start my career as a manufacturing engineer?
I mean, I think one of the things maybe I benefited from, and really trying to understand what areas I was really interested in, was I had a lot of varied experience because of the co-op program. So I had the opportunity to actually do internships with a number of companies in a number of different industries and sort of figure out what I was really interested in and what I wanted to do. So I think if any sort of opportunities for these internships come up, I think you should explore them early on to get that experience. And I think that starts to clear up the other question about what a manufacturing engineer actually does on a day-to-day basis.
Thank you. And Dean, you mentioned, Dr. Richard, you mentioned that after graduation, you worked in a factory that had manufactured. So what was your job, if I may ask, as a someone with control and automation skills in that workplace?
Yeah, so I explained this a little bit, I think, already, but basically my job was trying to optimize a particular manufacturing process that we had in our machine. So we were suffering terribly from reliability and repeatability in our process. We could run our machine for an hour and then it would, it would shut down. And things were overheating and things like that. So, part of my job was doing diagnostics on the system, collecting data, figuring out what was going wrong, building simulations of our system, and then prototyping different control strategies to try and fix those issues. And then also, actually, just to piggyback on Michael's comment about how to kickstart your career. I mean, so we're admittedly a small faculty right now within the department or within the program, but Dr. Najaran and Dr. Benoit or Michael will also have research programs that can involve undergraduate students, and the best way to kind of get involved with that is to talk to any of the research professors. I myself am also employing some students for curriculum development. So you're getting some kind of advanced experience in some of the manufacturing software, at least, that you might see in the industry.
Yeah, and I can just on that note, for almost from 2000 after my PhD till I was working on the unmanned systems and aerial vehicles. I can tell you the budget of my lab has been almost 10 times more since I switched to do research in the manufacturing engineering. There are just so many companies in need of automation, digitalization of their processes. It's a completely different world. If you look at the volume of work in the manufacturing sector, it's just mind-boggling compared to any other things. Remember that the health of a society, community, a country, and in its economy depends on how much you manufacture and how much you produce. Everything else is a liability to a country, from natural resources to healthcare and all that. They all consume money. The only thing that really generates revenue for a country is the manufacturing sector.
Thank you. I think we'll go to another question in the comments. I'm also curious on the types of computer science courses taught in manufacturing.
Yeah, so you take two computer science courses in the manufacturing program. Those, I would say, are more fundamental computer science courses. So just basically learning about, different data structures, different, just kind of in more advanced computing tools and skills. But to me, the interesting question is, where are those actually used in the manufacturing program? And that's actually my course. And we're going to be learning about programmable logic controllers, which are basically the brains behind an automated system. And all those computer science skills and courses that you're going to be taking are going to be used to help you in designing control systems.
Yeah. And also I can add a little comment, and that goes back again to difference between our electrical program and our mechanical program. So years and years when I was teaching, for example, my modern control course or the autonomous vehicle that Dr. Shirazi is taking care of, when a student comes to that course, typically students will flourish in that class who have, for some reason, they have good programming skills. And that has come by self-study, by their own interest. We do not want to take this chance in manufacturing program for our students, because all the machines these days, everything that you want to work on in a real world scenario, it requires understanding how these machines work. From industrial automation to robotics to autonomous vehicles, we do not want to take a chance. That's why this program has been designed in a way that we help you to gain that skill and experience, and not to take chances that we want to do this if, or you will excel if you have done this at home and by yourself. We make sure that you are trained on that.
Okay, the next question, moving on, says, what options are open to students in manufacturing engineering, mechatronics, biomed, and what other options are there?
I think that goes to the program. So I take the first shot at it, and then I ask my colleagues to help. So when you go, like anything else, when you want to introduce an option to a program, it takes some paperwork and introduction of certain documents that goes to the Senate and is approved. There is a lot of paperwork behind these courses that you take and you get credit for and you get your degree based on. So in my opinion, as a person who has been involved in designing and introducing the mechatronics option to our school, that ended up to opening this option to our mechanical and electrical student, I can tell you the closest program in our school to mechatronics is manufacturing. All of them, they have to tweak a little bit here, tweak a little bit there. For a manufacturing, the way we have designed it, it is actually mechatronics plus option. That is a little bit of upgrade than mechatronics. So it's quite intuitive that mechatronics will be an option. We started the process and it will be an option open to manufacturing students too. In other words, as a manufacturing student, similar to mechanical and electrical, you can be enrolled in the mechatronics option. Please note that mechatronics option has certain number of seats, so it's limited. Therefore, it is open for manufacturing students, but obviously not for everyone. So the seats will be filled with mechanical and electrical too. Does anyone want to add to this? No? So I add to my own comment just one more thing. If you want to be a mechatronics option engineer, and there is no seat available in mechanical or electrical for which to be a mechatronics in the end, the closest, as I said, is manufacturing. That training is very close to mechatronics anyway.
Thank you, Dr. Najran. Another question, since we don't have any more in the comments, I guess I'll ask one about, I don't know, Dean, if you want to take this one, sort of about the certification, kind of like the Festo stuff that's in the works for the program.
Yeah, so I think I mentioned this a little bit in my introduction, but we're working with Festo and another company called NC3, which is the National Center for National Coalition of Certification Centers. And they're a US-based nonprofit that offer these industry-recognized certifications. And we're trying to integrate those into as many of the manufacturing courses as possible. So the idea is that you do your course here at UBC, you have the UBC name behind you, you have all the prestige of the university, but then you also have these kind of third-party certificates that you can show a potential employer. And behind those, at the back of those certificates, you have some very tangible skills that a manufacturing employer would expect of a manufacturing graduate. And so we really think that this is going to kind of improve your hireability when you graduate from the program.
Miguel, do you mind if I add one more thing to Dean's?
Yeah, go ahead.
So I thank you, Dean. I think you covered that perfectly. Just one thing that goes back to our initial thought of this certification is that we have made a lot of effort and we've put a lot of discussions into this with Festo and with NC3 that we do not want our students to do additional things. So if you want to get this certification through other institutions, typically they require that you go and do this as additional credits outside your program during summertime, on your own time, and so forth. For us here is that you get the training that you want to do, for example, the exam for those certifications within your laboratory. There is no additional thing. So everything, and that goes with our sitting and designing our program from the beginning with these companies, making sure that what we offer is already approved by their training.
Another question just about, I think it was briefly touched on, kind of the what are the co-op summer and undergraduate research opportunities. I think research was touched on a little bit, but I think Dr. Benoit was mentioned about research. I don't know if you want to talk about that a little bit.
Yeah, sure. So I think for myself and also Professor Najrin, I mean, it's always useful to have more students in the lab to help conduct some of the research activities that we have going on. It allows us to do more research, but it also gives the students an opportunity to gain a lot of hands-on experience and conducting research and really developing an even deeper understanding of some of the topics that you guys touch on in class. But really in the research, we go even deeper in trying to understand some of these topics. So I think it gives the students an opportunity to really develop their technical skills.
And then I guess to kind of build on that, what are the graduate school and research opportunities after graduation for the manufacturing program?
Yeah.
Anybody wants to take that?
Maybe I can explain that, because if that's in the work now. We believe that having a graduate program for a school is a great thing, because with graduate students coming to a program, the program start to be both academically, intelligently stronger, and also graduate students help with building and supporting a program. So manufacturing, like all of our other programs, will have the graduate degree, and the work is in progress as we speak. We are going through the certification. Please remember that in this case, after the Senate is preparing all the material and is approved, then the Ministry of Education in BC also has to approve a new degree. So the work is in progress. Now, to the faculty members we are hiring who want to do research and have to hire, obviously the students can be electrical, mechanical, civil engineers, and working on manufacturing projects. So again, we are lucky in a sense that there is no boundary. In my own lab, I have computer science students who are doing a master's degree or PhD degree now. And I have electrical and I have mechanical students all working in the same laboratory towards their own degree programs at the graduate level. There is no boundary at our school. So one civil engineer can work on a manufacturing project towards a completion of a graduate degree. But we will have also a master's degree and PhD degree that is named manufacturing, Masters in Manufacturing Engineering.
Another question will be, what's the course load like? Like, would you recommend the 5-year program with 7 courses per semester, or what's it going to be like?
Rene, you've been there quiet. Do you want to take this question? I think that's right in your expertise.
If I can share the advising sheet for reference, if I'm understanding the question, it was just about course load per semester.
That was about doing a 4-year or a 5-year.
Oh, yeah. So we haven't. Oh, sorry. Looks like Dean's a step ahead of me here. Our SOE advising website will have all of those resources available to students under the advising sheet tab. So we have mapped out both the 4 and the 5-year degree option. I think we're just finalizing them now and expect them to be up by next week. So just visit SOE advising and you can plan your registration accordingly and connect with our advising team if you have any questions about just course selection and registration in June.
Thank you very much. So yeah, as Rene mentioned, our desire here is to be more flexible, or as flexible as possible, so that our students, depending on their living condition, and find their own option and move forward towards the completion of their degree. So the difference between 4-year and 5-year program is that when you're doing 5-year, you have less course load. Therefore, you can probably work better and increase your GPA in one sense. Or if you are even doing well, taking more courses and still doing well with your GPA, you may consider, you know, I take an extra year, but I go and work outside. Remember that in manufacturing program, even during your education, there will be a lot of interest in hiring you guys or new girls, going and working outside. So you may choose, I go 5-year program, but in the meantime, I make some money and also I gain industry experience on the way. So again, it's completely optional, it's completely flexible. If you do not want to rush within 4 years, we have the 5-year option.
Yeah, just to add to that as well, roughly 25 to 30% of our students are selecting the 5-year option exactly for that reason. Either they've got commitments to work or they want to participate in research, get involved in student design teams. So seeing more and more students selecting that option just to ensure balance between academics and other interests.
I have a quick question. I hope that you guys don't mind if I speak it. Speaking candidly, I still see going into manufacturing as a little bit of a risk. I see that the field is a little bit newer. Personally, prior to this year, I had never heard of it. Would it be, maybe not smarter, would it be a viable decision to choose mechanical simply for the fact that everybody knows what a mechanical engineer does?
I think I can take that question a little bit, and then hopefully my colleagues will be able to help. You know, it is like saying that it might be safer, but it is just safer because you're not going to be specialized. In other words, with picking something which is a little bit more general, you are transferring your troubles and difficulties to the future. That's the only thing that you may gain. Basically what you're saying, you know what, I don't want to be specialized now, I want to be specialized 3 years from now. But it's going to come. So now it's a matter of, you know, in terms of risking, you are getting still a UBC degree. You can do a little market search outside and see if manufacturing is a good job market. You can do a study on, for example, what is the starting salary of manufacturing compared to other disciplines, including mechanical, and see how many jobs are out there. Is the number of jobs going up and down? So I'm not saying that one student has to sort of take an uneducated guess and risk it. You as a student need to sit and look at all different options, look at how the future is going to unfold. Based on your interest, choose it. But if that moving towards a general area like mechanical, so that I take a less risk, I'm just saying that you are transferring the trouble. That study, you have to do it in year 3 anyways, to see if you are going to pick some technical electives, which field I'm going to go and be closer. It is a little bit, you're making that decision a little bit earlier. And why we do not leave it to the 4th year? Because when you're going to manufacturing, you need certain skills that is hands-on, and you cannot have it in 1 year. That's why we start, for example, with 230 in year 2 to give you that hands-on. And then we are going to boost it in year 3 and year 4. We cannot have a manufacturing engineer trained fully and efficiently in 1 year only.
Awesome, thank you. That clears it up.
My pleasure, Aidan. Thank you.
Yeah, maybe if I could just jump in on your response there, Professor Najrin. One of the things I found interesting about the question was that you said there's a bit of a risk because no one knows what a manufacturing engineer is, but everyone knows what a mechanical engineer is or what they do. So like I said, I actually did both my undergrad and PhD in mechanical engineering. And I think if you ask somebody at the beginning of the mechanical engineering program what a mechanical engineer does, if you ask 10 different people, you probably get, you might get the same answer, but you might find out there's actually, or 10 different answers, because it's not exactly clear what a mechanical engineer does. And I think what you find is that and I think Professor Najran touched on this, that as you start to go through this very general mechanical engineering program, there comes a point where you realize that you're actually very interested in one topic, not all the other ones. So for example, for me, very early on, I knew I was interested in materials processing, manufacturing. And in fact, I wish I had taken a program that was more focused in that and less focused on some of the other aspects of mechanical engineering, which didn't interest me at all. So I'm not sure it's a risk. I think in some ways it's actually a benefit, because you really go deeper into the topics you really care about.
I want to add a little bit more in that. Just being a mechanical engineering, if you join an industry, and in that industry, if you are being involved in the production, you have to go for master's or MBA. And here in this program, we have already accommodated a lot of about the production planning and and engineering management aspect also. Miguel can tell you, like, whatever they studied in 270, the fraction of that we are teaching in mechanical elective in fourth year, not all. Same, the manufacturing engineers, they have more hands-on experience on CNC machines, robotics, and all those, which are just fractions of that is for the mechanical engineering program. So you will be well trained for the industry, especially for manufacturing industry, which again, I said before, they are not accommodating right now most of the mechanical engineers. They are accommodating more the students from BCIT because they have more hands-on experience. So after this degree, you have even edge over the BCIT students because you have a design aspect also, and you have also production management aspect also.
Where can we find more info about manufacturing, engineering, and schedules, course load, everything? Where can we search for more information on all of this?
I don't know, Vanya, if you saw, I shared a couple links to stories in the group chat. So those would be good starting points. In addition, again, our SOE advising site does have all of the course registration and advising information. And if you had any more questions, I encourage you to connect with our faculty leaders in manufacturing and or connect with an advisor, and we can support you.
All right, thank you.
Yeah, especially Rani, during this 1 month, I appreciate that there will be some questions, regardless of how much you write in the websites. There is still some clarification needed, some questions unanswered. Please feel free to send an email, and we all try to be on it and quickly get back to you.
All right, thank you so much.
When is the deadline for the placement?
Yeah, so the deadline is May 31st. The link to the form was shared about a week ago, I think, with all of the first year transitioning second year students. So please submit your preference form, and then we'll get you guys organized prior to registration.
Okay, unless there's any last minute questions here, I think that'll be about it for questions, unless anybody has anything they want to add.
I don't have anything to add other than to say thank you to the students who showed up and are interested in the program, and we're happy to answer any questions you have, specifically about any of the courses we teach or our experiences or anything like that. It's a pretty unique program in that we're very tight-knit here. There's a limited number of faculty. There's a small cohort of students. So I look forward to getting to know everyone if you decide to choose this program.
I just see one last question from Cherry about the placement choice. Students benefit from being guaranteed placement in programs. Dr. Najran, did you have any comment? I know manufacturing does have a cap, so.
Yeah, right now we are hoping to get to 25 But I don't think, as you know, we do not have caps on our program. If we know early enough that the numbers are bigger than our target, obviously we can adjust ourselves and expand the labs. But the idea is not to have caps on our program. That is one feature we offer. Again, if I may say that, because manufacturing is going to be a big investment for the school, and it's a quite expensive program, to be honest, we need to look. But 25 is definitely not the limit. We are going higher. Dr. Sadiq, do you have additional comment on that?
No, definitely. We are in that stage. Trying to build this program. So we really appreciate students' interest. And I'm really glad to hear so many questions and inquiries about this program. This is excellent. I was not expecting that it's going to take that much time, and so many questions will come. I'm very happy to hear that there's a lot of interest. Yeah, so as Dr. Najran said, we don't have any limit on programs, but my feeling is this will always be a small and niche program. And we don't set a limit at this point. If we start getting hundreds of students in manufacturing program, definitely we put a cap, but this is not the time to put a cap on this program.
I want to thank everybody for coming out, all the professors, the School of Engineering advising team, Dr. Sadiq, Dr. Benoit. I didn't know you were still in Australia. I don't even know what time it is. Thank you everybody for coming out and answering questions.
No, really appreciate, it's very, very well done session, and really glad to see so many students are taking interest. And thank you very much for all the colleagues who showed up and all the staff who are sitting here on close to 6 o'clock. Really appreciate that.
Thank you. And also like to thank Vani and Miguel of nicely, beautifully organizing this for us. I really appreciate it.
No, thank you very much all. Take care, stay safe and healthy.
Yeah.
Thanks.
Thank
Bye,
you, everyone.
Bye, everyone.
Bye, everyone.
Hope to see you all in manufacturing program soon.